we are looking at the data sheet of microcontroller called AT89S52 microcontroller data sheet. So far we were discussing about 8051, 8051, 8051. And now there is one interesting thing called AT89S52. This looks a little bit different when compared to 8051. So now we are going to see the significance of this, and then we are going to discuss something about the Watchdog Timer. So AT stands for Atmel. There is a company called Atmel company who manufactures microcontrollers. The first two digits, AT stands for Atmel. 8 stands for like 8051-8. Here also it is 8051-8. That is the 8 indicates it is 8-bit microprocessor or 8-bit microcontroller. This 9 has its significance. Earlier it was 8051. Now here it is 89S51 or 89S52. So this 9 indicates it contains flash memory. It contains flash memory. So if you look at the feature here, the second feature is you can see 8 kilobytes of in-system programmable flash memory. So the 9 shows there is a presence of flash memory within it. So the presence of 9 indicates there is a flash memory. So flash memory is something like SSD memory. Flash memory is something like SSD memory. So just for 8 kilobytes of solid state device memory, that is the justification here. And yes, this yes denotes in-system programming features, that is ISP features. So ISP feature means this microcontroller can be programmed in the target board itself without removing the microcontroller from the target board. If it is not 89S series, that means if it is 8051 microcontroller, then it cannot be programmed directly in the target board. Meaning, if we want to program this microcontroller, the microcontroller IC has to be removed from the target board. It has to be inserted into the programmer. And after getting programmed, it has to be reinserted into the target board. Then only it can execute the corresponding application. After the invention of 8089S series, the programming is done within the system itself. That is, within the target board itself, it can be programmable. Within the target board itself, it is executable. So that is why the name in-system programmable. Because nowadays, there is no programmers available. The microcontroller within the target board itself is capable of programming by itself. That means directly it can be programmed without removing the chip, and directly it can be executed. So there is no need for removing the chip. Just like that, we can solder the chip. Programming as well as execution can be done without removing the IC. That is the significance of the letter S. So S denotes it is in-system programming facility. And 851 means 51 series, and 52 means 52. It is a series number. 8051 is the first series, 52 is the second series. So the only difference is 8051 has 4 kilobytes of internal flash memory. 8052 has 8 kilobytes of flash memory. And it has 128 bytes of RAM, but 8052 has 256 bytes of RAM. And in 8051, you have 2 timers. In 8052, we have 3 timers, 3 16-bit timers. That is the only difference. The rest of the thing, we have 4 parallel ports and 1 UART, and all other features are available as discussed. And our very interesting point here is the third point from the bottom. From the bottom, if you look at the third point, there is one interesting bullet called Watchdog Timer. Oh, there is a need for a dog. What does this dog do? That is the need of the day today. So we are going to look at the Watchdog Timer features of this corresponding microcontroller. So the rest of the thing remains same. So if you see the features, other features, it is compatible with 8051 MCS51 products. That means it is compatible with the 51 microcontroller products. So it is compatible means what we need to understand means 8052 is also having 40 pin, 8051 is also having 40 pin, and the first pin of 8051 is P1.0, and the first pin of 8052 is P1.0. So that is pin-to-pin compatibility. That is called pin-to-pin compatibility. So because of the presence of pin-to-pin compatibility, if we are using 8051 microcontroller in the earlier versions of the product, and if we are increasing the versions, means if the size of the program exceeds 4 kilobyte, just by replacing 8051, because the memory size is 4 kilobytes, if our program is 5 kilobytes means 8051 cannot hold the 5 kilobytes of memory. So instead of connecting the external memory by changing the hardware, which is much expensive, just like that, we can remove the 8051 microcontroller and we can insert the 8052 microcontroller, which contains 8 kilobytes of memory and 256 bytes, double the amount of program memory and double the amount of data memory, which is the convenience. So without changing hardware, or exactly speaking, without touching hardware, just by replacing the 8051 microcontroller chip with 8052 microcontroller chip, we can enhance the performance of the product. This is only because of pin-to-pin compatibility. So the compatibility means the pin numbers should not change in the higher versions of the controller, but the internal features has to improve. Say for example, 4 kilobytes of memory has become 8 kilobytes of flash memory. 128 bytes of internal RAM has become 256 bytes of internal RAM. So the program memory size is doubled and the data memory size is doubled. And you have one more timer extra, and in-system programming facilities are also available. But if we insert the pin number does not change. So it is easy for us to replace the 8051 microcontroller with 8052 microcontroller. And it is a very big advantage or very big convenience for the embedded design engineers, where there is no need for touching any hardware or changing any hardware. So if you go for the higher end, say for example, when we are assembling a PC, motherboard is coming from different company called something like Gigabyte, and the processor is coming from the Intel, and the motherboard should be in such a way that it can adapt Core i5 series or Core i6, Core i7 series or Core i9 series or Core i3 series, etc. So this is possible only because of pin-to-pin compatibility in the Intel microprocessors. Because when you want to upgrade the processing capability of the PC means, if the ICs Core i3 and Core i5 and Core i7 must have pin-to-pin compatibility, then only removing this IC and reinserting the other IC can enhance the performance of the motherboard as well as performance of the PC. If the pins are not, if the pin number of the corresponding ICs are not compatible means, you have to redesign the whole hardware. So to prevent that, all the next versions of the microcontroller pins must be compatible, whether it is a microcontroller or whether it is a microprocessor. So the prime objective of the microprocessor and microcontroller manufacturing people are, they have to design an IC with pin-to-pin compatibility. That is why it can go back to the earlier versions. It is in the hardware. In the software, we know if Windows 10, if there is a PowerPoint means, the same PowerPoint should open in the Windows 7. The same PowerPoint should open in Windows XP. Or any PowerPoint what we did with 2003, it has to support 2007. It has to be open in 2007. So that you call it as downward compatible, upward compatible. Okay. So it should be downward compatible as best as possible. It should be upward compatible as best as possible. That has to be, that is needed in the software side as well as that is needed in the hardware side. So that is the meaning for this word. Compatible with 51 products means all the 8051 series, it is 40 pin. The same 40 pin will exist in all the other versions. 8052 is also supporting the same 40 pin configurations with first pin as P1.0 and 20th pin as ground and 21st pin as P2.0 and 40th pin as VCC without any change. And that is the major thing which we need to understand. So there is a need for hardware compatibility and there is a need for software compatibility. All of us are aware of software compatibility. In the hardware also, the pin has to remain compatible. Then only the performance can be increased just like that by replacing the ICs. And that is the significance of the first feature. And the second feature is very simple. 8 kilobytes of in-system programmable flash memory is understood. So it is programmable within the board without removing the microcontroller. And please notice the 4 kilobytes of program memory has become 8 kilobytes of memory. And the supply voltage range is 4.4 voltage to 5.5 volts because it supports TTL logic. And fully static operation. That is a very important word we need to understand. Static. What do you mean by static? Static means it can work at 0 Hz to 33 megahertz. Now I like to highlight one point. When we talk about RAM, if the RAM should be DDRAM. Normally we talk about DDR4 RAM, etc. So this DDR4 RAMs are very cheap, and it can store large amount of data. They are all very cheap and it can store large amount of data. That's why we prefer DDR4 RAMs for the personal computers as well as laptops. But all the RAMs inside the microcontrollers are static RAM. So all our PCs has dynamic RAM. But all our microcontrollers has internal memory, internal RAM, but those RAMs are static RAM. Here in with respect to 8051, there are 256 into 8 bit, that is 266 bytes of internal RAM. This RAM is static RAM, it is not dynamic RAM. If it is a dynamic RAM, the storage element is a capacitor. Because the storage element is a capacitor, it needs some refreshing circuit. So unless otherwise there is no refreshing circuit, the capacitor will discharge and then it will lose the content of the memory. So that refreshing is not possible with 8051. Hence, the RAM should be the static RAM. But with static RAM, it is very expensive, and with very minimum, it occupies much space. Why? Because we need 6 transistors to store 1 bit if it is a static RAM. But if it is a dynamic RAM, only 1 transistor and 1 capacitor is more than enough to store a bit in the dynamic RAM. So approximately 6 times the hardware complexity is reduced in the dynamic RAM. But only limitation is because capacitor is used to store a bit, it has to be refreshed. So we need some continuous frequency to refresh. But the advantage of static RAM is it can work with 0 Hz. That is the significance. Because of the presence of static RAM within the microcontroller chip, there is a possibility for us to apply the static operation. That means even at 0 Hz, that means you can stop the crystal oscillator for power saving. So even if you stopped the crystal oscillator, the content of the memory will be retained because of the static RAM. So that is the magic, and that is the need for a microcontroller applications, because all the microcontrollers are mostly sitting in the standalone products which uses battery. So whenever necessary, then only battery has to be utilized. Whenever not necessary, always the processor has to be in the sleep mode or in the power saving mode or in the idle mode or power down mode, etc. to save the battery. So in that condition, it has to be with 0 Hz frequency, then only no power will be utilized. So for that purposes, static RAM is the only solution. Hence, static RAMs are most widely used. So just like that, we cannot celebrate static operation. To celebrate the static operation, the RAM should be the static RAM. So that is what I like to highlight by looking at these features for us to understand. So the RAM inside the microcontroller is static RAM, but the RAM we use it for our PCs are dynamic RAM, because it is less expensive and it can occupy very minimum space, and the storage capacity is more, because it uses only 1 capacitor and 1 transistor for 1 bit. So that is the advantage with respect to dynamic RAM. And 3-level program memory lock means, so to prevent to prevent the hackers to steal our programs. So there are memory lock available. So the program memory content cannot be read if we lock that program memory means. That is another interesting feature to protect our software from the hackers. And as we know, 256 into 8 bits of internal RAM, 32 programmable I/O lines. There are 4 parallel ports, and each port is of 8 bit. And there are 32 general purpose input-output lines, and 3 16-bit timer. There it was only 2 16-bit timer. Here it is 3 16-bit timer, and there are 8 interrupt sources. So there are another timer 2 means another interrupt sources has come. Hence, instead of 6, it has become 8 interrupt with respect to 8052. And as like in 8051, it has full duplex UART serial channel, and there are power down modes, that is low power idle mode and power down modes available, and interrupt recovery from power down mode. So there is a possibility for us to come out from the power down mode when interrupt comes. That means the mobile phone will be in the sleep mode. Whenever call comes, it will wake up and display something like that. It will recover from the power down mode whenever interrupt comes. So Watchdog Timer is the one what we are going to discuss in detail now, and the dual data pointer. So data pointer means the pointer which fetches the data from the data memory and give it to the processor for processing. The presence of dual data pointer means one data pointer can fetch the data from the internal memory, another data pointer can fetch the data point the external memory. So one data pointer can point the internal data memory, another data pointer can point the external data memory, which is another convenience for us. And there is something like power of flag, which to notify it is in power of condition or something. So there are so many interesting features. We have to celebrate more efficiently in a more comfortable way. But today we shall have the topic of discussion is Watchdog Timer. Okay, Watchdog. What is the need for this dog and why we need this dog, that we need to understand. Before that, we look at the block diagram, which is very interesting. So this is the internal block diagram of the 8052 microcontroller. So there are few added features that if you see, there are dual data pointers. There are dual data pointers. Here you can see there are dual data pointers. And there are watchdog timer here. So this is another new feature which you want to see. So this is the watchdog timer, which we need to look at. The rest of the features remain same. So there is a watchdog timer, which is interrupting your, which is available along with the timing and control unit, as we see. And what is watchdog timer? That is very important thing we need to celebrate now. What is the use of dog? Normally in our house we have a dog, right? Normally in our house we have a dog. So what is the use of dog? Dog will protect us from the thieves. Dog will protect us from the thief. Whenever thieves comes, it will bark and then it will wake up us. Similarly, the presence of watchdog timer is helping us to recover the microprocessor from the hanging condition. So look at the description here. So the watchdog timer is intended as a recovery method in situations where the CPU may be subject to a software upsets. Software upset means what? Whenever we become upset, what happens? We'll sit without doing anything, right? So software upsets, what does it mean is when the system hangs. When the system hangs, then we cannot do anything, right? Simply it will be visible. So we will press Control Alt Del, or we have to press the reset button to reset the whole system. So normally when the system hangs, what we normally do, we'll wait for some time, we'll press some or 2 or 3 buttons. If it is not working, then only thing is we'll go for task manager by pressing Control Alt Del button in the PC, or else simple solution is switch off the system and switch on the system or reset the system. Okay, so if any system hangs means the conventional way is to reset the system, to restart the system for normal functioning. So this restarting or resetting of the software is not available in the microcontroller products. Let us take TV remote control. There is no control all button in the TV remote control. Hence, it is impossible for us to reset if the system hangs. Even the Windows operating system, which was developed by a very high efficient engineers, and the Intel processor, which was developed by a very powerful engineers, even that itself hangs means a small microcontroller, there are n number of possibilities to hang. But those microcontroller based products do not have Control Alt Del button or reset button at all. Take for example, remote control do not have any Control Alt Del button or reset button. But there are possibilities to hang the microcontroller due to some unavoidable situation in the remote control. If so, what to be done is, it must identify the system got hanged. It must identify the system got hanged. It must identify the system got hanged, and after some time, so the predetermined time that we have to fix, after some predetermined time, it has to reset the system automatically. So for that, some timer is being used. So if there is a watchdog timer available, it will wait for some time, and if the waiting period is over, then what happens? It will ensure that the program or the corresponding function got struck, or corresponding function got hanged, or corresponding software was upset and it was idle due to some abnormal reasons. Then what it does, after that particular period of time, it will reset the microcontroller automatically internally, just like that. Now you can wonder how it resets automatically and how it can wait for some time. The sometime means the sometime is not in terms of minutes, that sometime is not in terms of hours, sometime is in terms of milliseconds, and sometimes it has to be in terms of microseconds. Wait for a few milliseconds. Within that few milliseconds, if that function is not getting executed, it has to come out from that function by resetting the microcontroller. So as we all know very well, whenever the time delay requirements are in milliseconds and microseconds, timer is the only solution, because timer is the only hardware module inside the microcontrollers which can produce the necessary time delay in milliseconds and microseconds. So here also we request timer to predict the hanging of the system, and after a period of time, still if the system software is in hanging state or in upset state, the only solution is to reset the corresponding microcontroller to start executing from the first location. So the time duration we can is fixed as some millisecond or something. If the duration is over, and it will reset the microcontroller automatically. We all know how to reset the microcontroller means. A time duration means there will be a counter, it will start counting. Whenever the counter overflows, it will set a flag. Similarly here also, with respect to 8051 microcontroller, there is an 13-bit counter. 13-bit timer is a watchdog timer. 13-bit timer means what? It can count up to 2 power 13. 2 power 13 is 8192. So it can count up to 8192 counts. After 8192 counts, it will overflow. If one count is 1 microsecond means after 8192 microsecond, it will overflow and it will reset the microcontroller. That means the overflow flag of the watchdog timer is directly connected to the reset, internal reset of the corresponding microcontroller. That is the very simple way. Now you are theoretically very clear about it. So there is an 8-bit timer, there is a 13-bit timer which is used for resetting the microcontroller. So whenever the system hangs, it has to identify that system has hanged, and then when it overflows, the overflow flag is directly connected to the internal reset button of the corresponding microcontroller. That is the significance of this watchdog timer. And it is very important. Using watchdog timer is a privilege in one context, and if you are not using the watchdog timer properly, so it will keep on resetting the microcontroller. If you do not know how to stop the watchdog timer, then it is a big disaster for the application. So if there is a facility, it can be used for the constructive purpose or it can be used for the destructive purpose. If you do not know how to use it for constructive purpose, it is better not to use watchdog timer for an application. Otherwise, it may destroy the whole product. So with this understanding, we will try to use how to initialize the watchdog timer. So here you can see using the watchdog timer. So if you want to enable the watchdog timer, we have to sorry. So to enable the watchdog timer, the user have to write 1E and E1 in the sequence to the watchdog timer reset register. In the special function register location, it is A6. So that means in the A6 location, it is mandatory for us to write 1E and E1 in sequence. That means first we have to write 1E in A6 location, then we have to write E1 in A6 location. This is the syntax for switching on the watchdog timer with respect to 8052 microcontroller. So if you give 1E and E1 in sequence, in the corresponding memory location of A6, watchdog timer will start. That means after writing 1E and E1, after 8 milliseconds, that means after 8192 microsecond, it will overflow and reset the microcontroller. That is what we need to understand. Okay, so that is what being written here, and we can very well experience this watchdog timer by using KEIL IDE. So for convenience, some code is being written, and by experimenting this code, we can simulate or we can experience how watchdog timer works. It's very interesting. So here we have written an assembly language program purposefully to show that 1E and E1 is written into the A6 data memory location, because just now we have seen in the data sheet, right? So we have to write 1E and A1 into the data memory location A6. You can see the screen, 1E and E1, which has to be written in the data memory location A6. To visualize it, we have used the assembly language program. So 1E is written into A6, E1 is written into A6 in sequence. Because it is written in sequence, it will start the watchdog timer. That is the one we need to understand. Okay. So if we see, only one line of code is available. That is XRL P0, hash 0xFF. What do you understand from that? Complement port 0. That means XR the content of port 0 with FF. Okay, if the content of port 0 is FF means, FF is XORed with FF means it will become 0. FF is, if 0 XORed with FF means it will become 1. So it will toggle the port 0. Okay. So now what we are going to do is, we are stopping the watchdog timer. So by I am commenting the 5th line and 6th line, so which says watchdog timer is not activated. Now, with respect to our understanding, it's a very simple code. So we can say again, once again, we can say this is the world's smallest code in assembly for us to understand. You can see org is an assembler directive. Org 000H means what? Origin of the program memory is 0000H. That means hexadecimal. So the program memory starting address is 0. That's all. The first instruction is XOR the content of port 0 with the immediate constants 0xFF. After XORing, stop the program. After XORing, stop the program. Stop the program means there is no stop instruction. Short jump here. This is a relative jump. So start jump here means it will keep on executing the 8th line forever. So only one operation it will do, which is toggling port 0. After toggling port 0, it will halt the program. That's all. So that is what we are going to experience here. So it is purposefully written to make it happen. So please observe carefully. So here we can see XRL P0, FF. So the P0 content is also FF. XRL is also, that is P0 is also FF. And immediate constant is also FF. So both are FF. So automatically the answer will be 0. Because when both are 1 1 1 1 1 1 1 1 1 1 1 1 XORed with 1 1 1 1 1 1 1 1, answer will be 0 0 0. After that, program execution comes to 8th line. So short jump here means what? Program execution will be there in the 8th line only. So even if I am running this code, even for 1 year, 2 year, 3 year, or even for 100 years, if it works, program execution will never come out from the 8th location. Why? Because it keep on executing the short jump here location. So it is nothing but jump here. Here in the sense, jump to 8th line. After completing this, jump to 8th line. After completing this, jump to 8th line. Jump to 8th line. H here means the label. It can be given as loop 1. Short jump loop 1 means it can jump to the loop 1. So that is what you need to understand. Okay. So first we need to understand this code. Now it is this short jump here. This 8th line is considered as system has hanged. Because it is not doing anything, it has hanged in one particular place. And assuming that system has hanged, that means we are creating the scenario like system has hanged by writing an instruction like short jump here. Now what happens if we activate or if we initialize the watchdog timer by using these two instructions, which is available in the 5th line and 6th line? Watchdog timer will start functioning. And because watchdog timer with respect to 8052 microcontroller is a 13-bit watchdog timer, it will overflow after 8092 counts. That means it will overflow after 8092 microseconds or 8 milliseconds. So after 8 milliseconds, watchdog timer will overflow and then it will reset the microcontroller. If it is resetting the microcontroller means what? Again microcontroller will go to first line. Then again it will XOR the port 0 and come here and hang. Again, if we are initializing this watchdog timer, every 8192 microseconds, that is for every 8 milliseconds, the microcontroller will keep on resetting. So how we can celebrate or how we can enjoy here is, even though there is a short jump here instruction, something like this, even though there is a short jump hanging instruction available, but port 0 will keep on blinking. That magic will happen. Why? Because system gets hanged, and we are enabling the watchdog timer every time. And because enabling the watchdog timer, and we are purposefully making the system hang. And after 8 milliseconds, it will reset. It will reset the microcontroller. After resetting, it will execute one instruction. Again, it will initialize watchdog timer, and again it will hang because the watchdog timer is being initialized. After 8092 microseconds, again it will overflow, and again it will go. This loop will continue. So even though there is a hanging code is being written, because every time we are initializing watchdog timer, it will keep on resetting the microcontroller. That is what we are going to experience by enabling this two instructions. So it's a very important thing which we can celebrate here. Okay. So now we have enabled the watchdog timer for convenience. There is a watchdog timer register also available here for our convenience. The timer, this watchdog timer here. So this is watchdog timer with respect to 8051 microcontroller. So if you look at the watchdog timer, here you can see reset sequence. If you look at the screen, reset sequence 1E and E1H. 1E and E1H. So that is what we have written, 1E and E1H. And after that, it overflow at 8091. It will overflow at the count reaches 8091. Right now, watchdog timer is off. When it will become on? After executing these two instructions, it will become on. Now let us see. So XRL port 0, MF is the instruction. 1 will become 0. This is just to identify that something is happening in the microcontroller. Yes. So XRL, this instruction has been written. So 1 has become 0. Now MOV A6, 1E has been written. You can see watchdog timer reset is the data memory address A6. That's why what we have written in the A6 is 1E immediately. That has come to watchdog timer reset register 1E as shown here. And again, now the sixth line is about to get executed. So that means we are going to immediately write E1 to the same A6 register. You can see I'm doing the single step execution. Now E1 has been written. So writing the sequences 1E and E1 will start the watchdog timer. Yes, earlier it was showing off. Now it is showing on. That means watchdog timer was switched on and the count has reached 2. Now the program execution comes to 8th line. Because the program execution is in 8th line, it will never come out from this loop. Why? Because it is an indefinite loop, or it is nothing but a hanging. It is the hanging notification. Okay, it is a hanging notification. Now I keep on running. So you can see the timer is counting. This timer is counting. So 60, 70, 80, 90, 100, 110, 120. It is counting the decimal count. It is doing the decimal count. It is doing the decimal count. When it reaches 8091, then it will reset. So if I keep on pressing like this, means it will take another few minutes to reach 8092. So what I can do is I can keep on breakpoint in the third line. You can see now I'm clicking once here. So some red color dot comes. This red color dot is a breakpoint with respect to KEIL IDE. Now I'm running this code. If I'm running this code, what will happen? When the count will reach 8092 and it will overflow after 8092. Then what happens? When it overflows, it will reset the microcontroller automatically. When it resets the microcontroller automatically means what? Program execution comes to the first line and it will come and stop in the third line because we have kept the breakpoint. As per the C syntax or as per the assembly language syntax or as per our understanding so far, the program execution should never come out from the 8th line. However, even if I am pressing this for another 20-30 years, for another 20-30 years, 8th line must only get executed. But there is a watchdog timer which is available. After 8092 counts, it will overflow and then come to the third line. So please try to understand, if the program execution comes to the third line automatically, means That itself is a miracle. That itself is a magic. This miracle or magic will happen only when we reset the microcontroller. That resetting is happening automatically through Watchdog Timer. That is the celebration. Okay, shall we experience that? Because now I am keep on pressing, but now count has reached only 600. It has to reach 8,192 to make it to reset. And 8,100 I cannot able to change the value also, so it is impossible. And so only way is to run this code. So now I'm running this code. We can see that program execution will come to the third line, and Watchdog Timer will remain in the off condition. You can see Watchdog Timer will remain in the off condition. You can see I'm running here. It overflows and comes to the third line. Now the program execution is coming, stopping the third line, which is the magic, which is the miracle. So it has come out from the hanging condition. When the Watchdog Timer overflows, it will come out from the hanging condition. Now again, what happens by XORing L? It will do the remaining job. But purposefully, we are initializing the Watchdog Timer again by reloading AC 1E and E1. Now you see Watchdog Timer is in off condition. You can see the screen. Watchdog Timer is in off condition. Now we are going to write 1E and E1. When we do this in sequence, Watchdog Timer will switch on. Then system has hanged again. We are purposefully starting the Watchdog Timer and we are purposefully hanging the system because we have enabled the Watchdog Timer before hanging. Watchdog Timer will overflow and then it will reset the microcontroller again and again and again and again. Now we see again, you can see, now I keep on running, right? Resetting, overflow, that is enabling the Watchdog Timer and hanging. When it overflows, it is again resetting the microcontroller again and again. Because of breakpoint, it is happening. We look at the bottom left corner. There is a text here, Watchdog Timer reset occurred, Watchdog Timer reset occurred. That notification is keep on coming. Fantastic, right? So now I'm removing the breakpoint and we are making it happen continuously. You can see continuously Watchdog Timer reset is happening again and again and again. You can see just keep on blinking. Port 0 is blinking, but it should never blink as per this instructions because it should never come out from the 8th line. The program execution should never come out from the 8th line with respect to the syntax. But the miracle is happening, port 0 is blinking. So this blinking is because of continuous enabling of Watchdog Timer and continuous overflow of Watchdog Timer. This is continuously happening. Because of that, this hanging is overcome. So system got hanged, it is overcome by Watchdog Timer overflow reset. Okay, so like this, any software hangs in any of the embedded systems. The presence of Watchdog Timer, when it is utilized efficiently, it can reset the system automatically, and it will make the embedded systems to work perfectly without the knowledge of the user or the engineers, without the application, without the nature of the user. For example, TV remote control may have Watchdog Timer. At some unavoidable situations, it may get hanged, but some program has been written through Watchdog Timer, so it will reset automatically within few milliseconds. Something like you can see within 10 milliseconds, this will reset and it will re-enable everything. So where the user cannot able to notice that resetting nature of the corresponding applications. This is the magic of Watchdog Timer, which is available in the AT89 microcontroller itself for us to celebrate. And this much clarity and this much convenience is possible only when we experience it with 8-bit microcontroller. That is why we have chosen 8-bit microcontroller to understand and experience and simulate and demonstrate the working nature of Watchdog Timer. Thank you.